Let's see how we might use Coulombs law to compute the potential energy of interacting charges. It shows how energy changes when the magnitude of the charges change, or when the distance separating the charges changes. We will also discuss what constitutes high energy and what constitutes low energy when charges interact with each other. The full form of Coulombs law for calculating the energy of interacting charges is shown here. Since our long-range goal is to compare energies as charges or distance change, we will use the simplified version of Coulombs law. This would give us a value of energy in units of K over epsilon. Let's first look at the interaction of like charges. Although in this picture they are both +1, they don't have to be the same number, just the same sign to be considered like charges. We have them 1 unit of distance apart. We'll use the simplified version of Coulombs law. Substituting the charges and distance into Coulombs law, the energy equals 1. Moving the charges closer together to 0.5 units of distance changes the energy. Using Coulombs law, we find the energy equals 2. Like charges can also mean that both charges are negative. Notice that if we have two -1 charges instead of +1 charges, the resulting energies are identical. When we consider the energy of interaction between opposite charges, such as a +1 and a -1 charge, the only change in the Coulombs law expression is the sign of one of the charges. This results in an energy of -1. If the charges are separated only by 0.5 distance units, the energy becomes -2. No matter what the distance, opposite charges always give negative energies. Note that the distance is always positive. We now make an important definition for ranking the energies of different charge interactions. We define lower energy as a more negative, or less positive, energy. If we were to rank the 4 scenarios from the previous pages, the lowest energy scenario would be the opposite charges closest together. The highest energy scenario would be the like charges closest together. The interaction of opposite charges will always be at lower energy than that of like charges. Notice that 0 energy is in the middle of the range. In summary, Coulombs law can be used to compute the potential energy of interaction between two charges. Like charges will always have positive energies, whereas opposite charges will always have negative energies. We define lower energy as the more negative energy. Higher energy is a more positive energy. We note that both the magnitude of the charges and the distance separating them affect the energy.